Good day, everyone. In this session, we will dive into an essential topic in physics, forces, focusing on Newton's first law of motion, free body diagrams, and moments of a force. These foundational concepts are key to understanding motion and equilibrium in various systems. Let's get started. An object remains at rest or in equilibrium if the external forces acting on it are balanced, meaning the resultant force Fr is zero. To illustrate, think about an object sitting on a table. It doesn't move because the forces acting on it, such as gravity and the normal force, are balanced. Here's a fun question to get you thinking. Which is easier to pull with one hand? The roll with more toilet paper or the one with less? The roll with less toilet paper is easier to pull. What is the explanation? This ties to the concept of inertia. Inertia is the resistance of an object to a change in its state of motion, and it depends solely on the object's mass. A roll with more toilet paper has greater mass, which means it has greater inertia. As a result, it resists motion more than the roll with less toilet paper. Therefore, less force is required to pull the roll with less toilet paper, making it easier to pull. By the end of this lesson, you should be able to 1. Identify various types of contact and non-contact forces acting on the body. 2. Draw free body diagrams to represent forces. 3. Determine whether the external forces acting on the body are balanced. 4. Determine moments and solve related problems using the principle of moments. These objectives will guide us as we delve into Newton's first law and related concepts. Newton's first law, also known as the law of inertia, states that an object will remain at rest or move at a constant speed in a straight line, unless acted upon by a non-zero resultant force, or unbalanced forces. This means if there are balanced forces, an object won't change its state of motion, that is, it stays at rest or continue its state of uniform speed in a straight line. Remember, inertia depends only on mass. The greater the mass, the greater the resistance to motion. A force is an interaction that causes a push or a pull on an object through an agent. It's a vector quantity, meaning it has both magnitude and direction. Forces can be classified as contact forces, such as friction, or non-contact forces like gravity and magnetic force. Now, what does a force do? A force can 1. Accelerate an object, 2. Decelerate it, 3. Cause it to rotate about a pivot, creating a turning effect, 4. Change its direction, 5. Alter its shape, 6. Modify its size. If any of these effects occur, a non-zero resultant force must be acting on the object. This illustrates the relationship between force and motion. In conclusion, Newton's first law provides a framework for understanding motion and equilibrium. Forces influence how objects interact, and the concept of moments adds depth to this understanding, particularly in rotational systems. Next, we will practice applying these principles through examples and problems.